What are some common misconceptions that you see people having about quantum computing, people who are even tech savvy in the other industries as well?
Well, I'm even now surprised after many years of giving talks and talking to people that there are many, many misconceptions. In fact, a couple of years ago, I was asked to write an article for a magazine here in Spain, and then it was later republished by BBC.com on the myths and realities of quantum computing, what people think quantum computers are and what they are not. And in fact, some of the ideas in that article are included in the first chapter of the book, because I find once and again that people think that quantum computers are magic devices that solve any problem. We all have heard this idea that quantum computers explore all the solutions or all the options at once, and then something magical happens and the problem is solved. And this is something that, to me, it's kind of surprising, because when I was not yet studying quantum computing, I used to read this news or these popular science books. Oh yeah, this is what happens. Quantum computers just explore everything at once, and I didn't understand what that really mean. But then when you study the algorithms, you notice that, well, this idea of using superposition, of like exploring all the options at once, is just a tiny part of the algorithms. It's just the beginning. You can do this quite easily, but then you have nothing. You have to work a lot in order to retrieve the actual solution and the value from all those options, and to make more likely to, when you measure the state of the computer, to obtain an actual useful result. And then this is something that we have tried to make clear throughout all the book, that the role of interference. People think that superposition and entanglement are the main ingredients in quantum algorithms, and of course they are very, very important. But to me, interference is the unsung hero of quantum algorithms. Without interference, you get nothing. So this is a very common misconception, that, well, just rely on this superposition and everything falls in place, and it's not true. It's not true. In fact, for instance, in Grover's algorithm, most of the operations are trying to improve the odds that you find the element that you want to find. And this is done not with superposition, but with interference.